Okay, welcome everyone again. Next topic is the Woman-Machine Alliance, how human input optimizes AI results for businesses. And our next speaker is Andrea Sperduti. He's from Italy, and welcome to Data Science Conference. The floor is yours.
Okay. So good afternoon, and thank you for everyone to be here today, to attending my presentation. So before I start, I would like to say the original speaker was Elena Morocco, that she couldn't attend today's presentation as a speaker, so I'm replacing her. I'm Andrea from Italy. I'm working from Evo. We are an artificial intelligence company, and I'm going to tell you more about how human input optimizes artificial intelligence results for businesses. And the reason why this presentation main title is the Woman-Machine Alliance is because Elena was one of the main developers of the tool that I'm going to introduce you right now. So let me start introducing Evo, the company which I work for. So Evo was born in 2013 from the PhD thesis of our CEO, Fabrizio Fantini. PhD in mathematical applied mathematics, and then since that year we start to work with other with a lot of retail company and retail firm around the world, and to collaborating with some other institution from university point of view. And so those are the phases of some other colleagues and co-workers. So what we do is basically we help retail firm and company to increase their revenues or optimizing inventory, helping them during markdown season and, for example, other things like pricing and so on. So we help managers, as the title says, to create value from science. They provide us a lot amount of data coming from daily transaction, number of stock pieces that they have in the warehouses and in different stores. And then we try to transform this data in some interesting KPIs that can be used to optimize and to improve their revenues, for example. That's one of the possibilities. And as you can see, those are some of the examples of our clients. So we have for example, this 16.2 revenues for Miroglio Group. That is something that I'm going to discuss later about this. Or also some margin points and also improvement of inventory efficiency for different companies. So today is going to tell you a story. It's basically a story of how we faced a problem, and now we try to overcome this problem with our solution, with our products. So I will guide you through the context of this problem, what was the original issue, how we decided to tackle this problem, which was our solution, and then the impact and the results that our solution had on the original issue. So the client that I'm talking about is Miroglio. Miroglio is Italy's third largest retailer of women for premium and plus sizes. He has revenues of $500 million. And he has more than 1,000 stores, all spread over Europe, with 11 different brands. And the main problem with Miroglio is that they have so what they put in their stores for their brands, they have a very short life cycle items. What does it mean? That every 6 months, they change the items that they do have in the stores. So there is like a summer season and a winter season. So every 6 months, they have to change this. So why this is important? Because this means that there is a wide variety of each item with different sizes spreading in all over the stores that have a very short life cycle. And the challenge here is try to optimize the number of stock out pieces. So it means that, for example, when you go to a store, you go to your favorite store and you want to buy let's say, a particular red t-shirt, but that red t-shirt is not anymore available. So that's a stock out, because the store would have made money if it would have sold that particular t-shirt. So it's a bad news for the store. On the other hand, there are excess items. So there are some items, for example, blue t-shirts, that are not sold anymore. And it's a cost for the store, and it's a cost for the company to keep them in the warehouses, for example. So we need to understand how to optimize these two things. So the question that I would like to address and answer today is, what's the right number of pieces in a particular size of a particular item to send to every store in a given week. This sounds like something very challenging and complicated, but at the end of the presentation, you will be an expert of this supply chain methodology. So let's start from our solution, what we propose as our main solution. The first thing to do is to propose an optimized replenishment, so from the central warehouses to the stores. So the stores, they need to have a certain amount of pieces for each item for a different site, and we need to optimize how to send these items from the central warehouses to the individual stores, okay? Without going in stock out and without having more than what is needed in terms of items. And also we can use a rebalance application. So if we have a store which is selling a lot of items, let's say those particular red t-shirts, but there is another store that is not selling anymore these red t-shirts, we can move these red t-shirts from that store to the first store. Because in this way we will avoid to have a stock out in the first store without having any consequences on the second store, for example. And the third point comes to the title of the presentation, so the human alliance with artificial intelligence. Why this is very important? Because in this process we have engaged the store managers, and I will tell you later how does it work. So we need to have from them an input that what we are doing is right, and they have the possibility, they have the power to change our advice and our suggestions according to their experience and how they well know the customers in their stores. So let's go through what we propose as a solution. So this looks like a little bit complicated scheme, but I will guide you through this, and everything will be clear. So the top box in the middle with this light green, it means that we need to get data from the company. So from IT of the company, we need to get data, and this data represents all the transactions that have been done in the past at the granularity level of sizes. So it means that we have a database with all the information about the items that have been sold for a particular size in a particular store at a particular day. See, this is the smallest granularity ever level possible. And then we also gather information about, say, inventory. We need to know how many pieces of that particular item are stored in the warehouses and in the stock of the individual stores. So once we've done this, we want to estimate the potential sales. And this is done with an algorithm that I will tell you later how this is achieved. So once we have once we have done a forecast of the future, we want to define 3 different KPIs. The first one is the order missing pieces. So like if we have a missing pieces in some store and we want to avoid stock out, we must know how many pieces of that items we want to send to that particular store. Then we have the release of exceeding pieces. So if a store has, let's say, 10 blue t-shirts that are not sold anymore, but they are needed to another store, those 10 t-shirts can be sent to the second store because they are not needed anymore to the first store. And then we have a budget. And budget is a KPI that we are providing to the manager input, and I will tell you later how does it work. So once we have collected these different KPIs, we gave them to the manager input. We gave them as input to the manager. So we actually gave our data, our results to the manager of the stores, and they have the power to change what we are proposing, to change our suggestions. Finally, once this has been decided, once the manager is happy with what has been calculated and forecasted, we proceed with optimization. So we have business constraints that must be met, some condition that must be met. And what we do through this optimization algorithm, we are able to optimize the stock allocation, maximizing potential sales, and minimizing, for example, logistic costs, such as the cost of moving one box full of t-shirts from store A to store B, for example. And then finally, once we have done this optimization, we must trigger the different movements, which means we must trigger the order from the warehouses to the different stores, and then the transfer between the stores. let's start with the first part about the estimating potential sales. So this is, of course, I would say, easy algorithm, but it works very, very good. Of course, we can use any other kind of regression approach that is going to forecast our quantity in the future. So what we do, we start from a higher level of aggregation. So we don't start from item store sites, but we start from item store. If you're wondering why we're doing this, it's because at level of item store sites, it is very noisy. We have very few items for that particular day or for that particular week. So in order to improve our model, we need to start from a higher granularizing level and then go down to the lowest possible level. So what we do, we took the recent past sales for the let's say a sort of responsiveness period, which can be 1 month in the past. So now we are almost in the end of November. In my case, I will get all the past sales, let's say from the beginning of November until now. And then I sum up all the items that have been sold in different stores. Then I get a quantity, and then we sum this quantity to the estimated lost sales due to stock out. So why I'm doing this? Because if you do this, you're really, let's say, you're trying to calculate a real demand. You're really trying to calculate a real quantity, which is not taking into account the fact that there's been some stock out. This is very important because it's a very strong point in our model. And then you need to, in order to move from that quantity, from this quantity in the past to the future, to project this quantity in the future, we need to multiply this by a seasonality factor. And this seasonality factor is obtained by normalizing the number of sold items for all the previous years that you have in your database of data. So let's say from 2015 to 2019, for example, something like that. And then you get your estimated future sales for the coverage period, which can be the next month. So I want to know how much I'm going to sell in December, for example. That's one of the possible applications. But as I told you before, this is not the lowest aggregation, the lowest possible aggregation level. So we need to move from store item to store item size. And in order to do this, we need to calculate the frequencies of pieces sold by size for 2 different items. For example, what I'm showing here in the histograms on the left, those are 2 items, item A and item B. And this is the frequency, so this is just a 1D histogram of the sold, of the number of quantities that have been sold grouped by size. So as you can see, 2 items have a different distribution, which is, I mean, is always supposed to be. They cannot be the same unless they belong to the same category, for example. And then we try to do the same, constructing another 1D histograms where we have frequencies of pieces sold by size for 2 different stores, grouping by all over the items. So as you can see, store X and store Y, they do have a different distribution because, for example, because they have different customers and they have different needs. So once we've done this, we sum them up with having a weight of 0.5. So it's sort of average of them, of the frequency. And once we have got this, the size frequency at item store level, we got the quantity that we have previously calculated with the previous method, so the estimated future sales, and then we project them in the distribution. So we know that we must have 10 items, so 10 red t-shirts that are sold in that store, and of 10 red t-shirts, we have 4 XL, 4 L, and 2 XXL, for example. The sum has to be equal to the estimated potentials. And that's why we move from the store item level to the store item size level. Then once we have calculated this estimated potential sales, we need to provide to the store manager these 3 different KPIs. So the order missing pieces, the budget, and the release exceeding pieces. So how we do calculate them? So first of all, we need to provide a KPI, which is this is given by the difference between the estimated potential sales and the actual stock. So if this number is positive, it means that you're going to sell a lot of that particular item. So the risk is to be in stock out. So you need to get more items in your store. If this number is negative, it means, of course, that these items is not sold anymore in your store, and you need to, for example, to give it to another store, to release it and to give it away from your store. So the suggested operations can be order, so require one or more missing pieces from the warehouse or from the other store, or release. So move one or more pieces from your store to the other stores that maybe needed more than what you do. And then we also define a mandatory release. A mandatory release is a sort of forced withdrawal of one or particular pieces of one particular item that is not going to sell, because for our estimation is an item that will not give you any kind of revenues, because no one, for example, want to sell it, or it's out of season, for example. That's one of the possibility. Then, as I told you, we define a third KPI, which is the store budget. So it's a sort of monetary budget, right? It's given by the difference between estimated potential value and the stock value. So it's very similar to this one, but in this case, we are talking about euros or dollars or whatever. And then we had an extra overage. This extra overage can be seen as a sort of insurance. It's like you're saying that, okay, I'm believing my estimation. I really want to follow what I'm saying, but at the same time, I want to be sure that I'm not removing all the items of that particular, all the items from that particular store, because it's, you know, it can happen that you might want to sell them at some point during the campaign or during the season. And that's where the human artificial intelligence alliance start to play a very fundamental role, because we gave all this information to the store manager of all the stores, of all Miroglio stores, for example. And what we provide them is a dashboard, is a store manager interface, where they, for example, can see on the left, we have this dashed rectangular box where it's written search box, where they can find for the particular category of the item, a particular item with a particular size. And then they can make a filter by item tags. For example, you can look for trousers, t-shirts, coats, whatever you want. And then there is this editable cells in the middle, this one with this big rectangular box, where they can change our suggestions. This is very important, because actually the store managers can give some further suggestion to what we have calculated, to what we have proposed. Because, for example, if you are a store manager and you have a client that comes to your store and is asking for a red T-shirt, and that red T-shirt is not available, the only person that at the end of the day will know that a lot of people, for example, ask for that particular T-shirt is the store manager. So that's why this is very important, because the store managers know something that it cannot be represented in data. No one is going to write down on the data that day some people came and asked for a red T-shirt and the red T-shirt was not available. But the store managers, we know this. So that's why we need help from the store managers, because they can change our suggestion according to what they think it's better for the customer, because they do know the customer better than anyone else. The only thing that they can do is to go below this the budget. On the right top of the figure, there is this delta budget, which is the budget that we have been calculated before. And every time they, change the number of released pieces, number of pieces that have to be moved from different stores or from the warehouse, this number cannot be negative for obvious reason. And another thing that they cannot change is when our algorithm is telling them that there is a mandatory releasing of the item, they cannot change it. They have to follow it, because that's very, let's say, it's dramatically true that that item cannot be sold anymore in that particular time period. And then we come to the allocation based on the artificial intelligence, to optimization algorithm. So that's how, in a very simple way, our optimization model works. So this is valid for one item in one store, but of course it can be extended to a different multitude of items in different stores. So what we do, we start from a Poissonian distribution, which tells us the probability of selling the nth piece. So what does it mean? It means that the probability of selling the first item of a stock of item, let's say you have 100 red t-shirts, the probability of selling the first red t-shirt, it's higher than selling the second, the third, the fourth, the fifth, and the last piece of your stock. So that's why you have this curve, which goes to 0. Then you need to multiply this number by the average price of a product, because you want to know what are the revenues that you're going to get, right? The revenues that you're going to get with n shipments. So this curve here, this plot which says total revenues with n shipments, is basically telling you if you're going to ship 100 items to another store and all these items are going to be sold, you're going to maximize as much as possible your revenue, which makes sense. The higher the number of items that you sold, the higher will be your revenues. But of course, you need to take into account also some other factors, like cost of n shipments. The higher the number of items that you want to sell you want to send from the warehouse to the stores and from the stores to other stores, it's let's say more or less directly proportional to the number of items. So it's like a straight line, right? In reality, this is not really true, because actually you don't pay for the single item. You, for example, put all the item in a box. So what you do, it's pay for the number of boxes. So if you want to show this curve as it's supposed to be, it should be like step function, where you have the plateau. It means that is a single box, and then when you need to that particular box is full of closures, you need to have another box, and then the price goes up again. So once you have done this subtraction, so you're removing the cost of n shipments from your total revenues with n shipments, you end up with the last plot on the bottom of the slide. So the net profit with n shipments. And as you can see, this curve has a maximum. And this maximum corresponds to the optimized number of items that you need to ship in order to maximize as much as possible your profit or your revenues. So this is, of course, a very easy way to describe this optimization model, but it works even for 1,000 of items in 1,000 of stores. And of course, during this optimization, beside the logistic constraint given by the cost of the shipments, you need to also take into account the constraints which are given by the client. And this constraint can be, of course, you have your central warehouse or your store, and you can send at maximum 3 different boxes to other stores. So this is something that has to be put inside your optimization algorithm, because otherwise your solution will not be right and will go against the business rules. Another possibility would be that each box has to have at minimum 7 pieces, right? It cannot have 6 pieces. It must have at minimum 7 pieces. Otherwise, it's not worth it to make a box and send the items to another store. And another example can be the price, the cost of the box, the value of the box, which can be minimum 150 euros, for example. So the value of the items which are inside the boxes must be minimum 150. And those information goes inside the optimization algorithm, and what at the end you came out is a solution that satisfies all these constraints. Fine. So once we have done this optimization procedure, we are ready to give to the client what are the action to take. And we provide them our suggestion in 3 different outputs. So the first one is for the central management. So we gave them an automated spreadsheet, like an Excel file, for example, with all the information about the movements, detailed information about what has been done, and also we provide an online dashboard to visualize the statistics of the shipments and, for example, how the revenues has been increased and so on. Then for the client IT department, we provide them a CSV file, which directly goes into their system, and they can trigger the shipment from the warehouses to the stores and from the different stores. And instead, for the store managers, we update the dashboard that I showed you before. In this way, we can show them what kind of suggestions that they give us has been met and how their proposal, their solution has been implemented in our model. And they can see what, of course, what will be received from the central warehouses and what will be sent between the stores. So now that I tell you how the model works and what is the idea behind this, it's time to see if this model had an impact and which are the results. So since this was a pretty new model, never been tested in reality before, we decided to involve only 2 brands of the Miroglio group out of 11, as I told you before. And this test goes from April to June 2016. So we're talking about a couple of 3 months, something like that. And since it was a new method, it's not been applied to all the stores. So we divided in test stores that were using our method. We're using our replenishment tool, because it's a tool, it's a product. And then those that were based on the usual approach that they used to have in the past, so the control group. And as you can see, the results are striking because the test stores have an increment in the sales of around 16%, which is impressive. And in addition to this, we also computed some other metrics, some other factors that can be useful for the client, such for example, shipment success, which basically tells you what is the percentage of the items that you have been shipped that have been sold. So in the control stores, we had a 53%. Instead, in the test store, we had a 58%. So it's an increment of 5%. And then we have other information like sales to shipments, the stock velocity. So how quick was your stock to be sold? And then, for example, demand cover and so on. But as you can see, in average, if you take an average all these parameters, you see that there has been an impact of 5%, which is very important because Miroglio was super happy, and now since that day, has always been one of our clients and is still keeping using our tool for different application in almost all the brands. We also got a positive feedback from the store managers because if you remember what I told you at the beginning, we gave our optimization, we gave our suggestion to the store managers, but the store managers are not forced to change them. If you are a very lazy store manager, you can say, whatever you say, it's fine, let's just send it to the store, I don't want to see. But it's not the case, because almost 80% of the store managers kept changing our result, kept working with our tool. And this is very important because this is what gave you a difference in terms on the long term, in terms of revenue and in terms of sales. And in particular, they changed something like between 15 and 20% of what we have initially proposed. So it's a good number. It's a 1 out of 5. I mean, they were pretty happy with 80% of our suggestion, but they need to change the other 20%. And I would like to point out, I would like to stress out that this 20% usually represent a very special product. For example, products that are new, never been sold, products that for some reason are very difficult to forecast, products that have a very different seasonality factor from the others of the same categories. So very special items. Yes, and before I end the presentation, we also provide them another metric, which is called the popularity index. So the popularity index is the ratio between the ordered pieces minus the released pieces divided by the stock, the number of stock pieces in the inventory. And this is a number which goes from a minus 100 and plus 100%. And what it's going to tell you is that if an item has a very high percentage of popularity index, it means that this item needs to be restocked because it's selling a lot. It's an item that all the customers want it, and you want to sell it because you want to maximize your revenues. But if you have an item which instead has a negative value, it means that this item is not sold anymore. And this is clear because the number of releases pieces in the equation will be higher than the one that are ordered. And this means that you have to take some action. You have to counteract this effect. And possibilities are to make a promotion, a discount, for example, during, I don't know, discount season or Black Friday. And another possibility would be to remove it because it's not selling anymore and it's not good for this. And in particular, we provide this popularity index to the store manager of the central warehouse, so he can actually see what are the impression of the different store managers about the different items. And this can also provide a sort of proxy for future items, because if you have an item which is similar category to this one, then and is going to be sold in the future, you can apply, for example, this popularity index, and you will know how this item will sold. So I would like to conclude to say that usually business people and store managers are very scared by artificial intelligence because they cannot really see what is going on, and they just see, you know, like they got our suggestions and they don't understand where this is come from. But with this method, it's also very easy to explain them what is going on, and they can be part of the process and they can be part of the forecast. So, and this is very good, both for us and both for them. So, thank you, and I'm ready to take in your questions.
Thank you, Andrea. Do we have any questions for this subject? Okay, I will ask a short one. On your opinion, what is really crucial when it comes to AI adoption? Because I really loved your case and what you did in Evo company. So in your opinion, how we can increase and explain more to people what, as you said,
yes,
during the AI adoption cycle, what is crucial and important?
Yes. So I think what is crucial in terms of explain to other people of from the business side what they do is to try to engage them in the process, as we did for the replenishment tool. They have to understand they are part of our decision. They have to understand that their opinion is very crucial for the final results. This is one of the possibilities. And of course, when using very fancy neural networks with 1,000 layers and so on, it's always very difficult to try to explain this to people working in the business. I mean, as I said at the beginning, we could also use different methods to forecast our sold items. But using this method, which at the same time is easy to explain and it gives a very affordable and reliable result, is a win-win combination, because it saves us from developing very difficult models that would be difficult to tell to the business people, and at the same time they really know what is going on and they feel like they are part of the process, which is the most important thing.
Okay, thanks a lot.
Thank you.
I appreciate it.